What's up, everyone? It's Alex, and we are doing day 6 of Advent of Code in fourth. So this problem will probably bring you back to middle school algebra. Uh, you know, trains arriving at stations at certain speeds and all that. So essentially, what we have to do is we have three times and three distances, and then we have a boat, and the boat will you charge it up at a certain speed, and based on how long you charge it up, it goes it goes faster essentially. And you want to see all of the integer numbers that you can charge it up that causes it to go farther than the target distance. And so in part one, we have three times three distances, and you have to multiply the number of integer times that you charge the boat together and get your solution. And then in part two, you just combine all of the times and distances into a single value, and you just do the race a single time. So let's go to my solution. So this one took me a while, and the reason is the main challenge that I had was that you need 64-bit integers. So if you actually look at the input, I'm not going to show my input on screen because the creator says don't do that. So if you look at the input, you end up with a distance that is a 64-bit number. It's like gazillions. That's the scientific mathematical term. And then you have a time that, like, when you square it is also really, really high. Or like divided by 2 and square it is also really high. And so you need arithmetic that is 64 bits. And Dusk OS does not have that. It is a 32-bit operating system, and so there are no 64-bit constructs. Most fourth systems are either 32 bits or 16 bits. And the way that you handle longer length numbers is you use two-cell arithmetic. And if you read the book starting fourth, there's an explanation of what two-cell arithmetic looks like. I got this from UF, which is a 16-bit fourth that is like took it from somewhere else. But essentially, you have to define all of these arithmetic words in order to do two-cell arithmetic. And so doing two-cell arithmetic in fourth is somewhat challenging because you have to think about like two things on the stack. And then if you're like adding or multiplying something, you need to think about like two items and then two other items. And the items represent the lower and then the higher half of the two-cell number. And this is all very confusing. So fortunately, I didn't have to write this. I used Felix Winkelmann's implementation of this library and then just modified it a little bit for Dusk OS. But this gives us the ability to work with 64-bit numbers in Dusk OS. So once we have that, part A doesn't require 64-bit, but part B does require 64-bit bit numbers. And so I had to rework my solution in order to solve part B. So for part A, so this is how we do the input. It's relatively straightforward. We define time and distance to do nothing. And then we just allocate distances. Then we just read the input through the fourth interpreter, and that just puts all the numbers on the stack. And then we consume the distances and we consume the times off of the stack. And because it's just 4 values, I just do four bytes. Relatively straightforward. And then, so for part A, we iterate from 1 to 4, and then we select the times and the distances, and then we use the above function, which gives the number of values that are above the target distance. And then we multiply all those together and we get the answer for part A. So the way that above works, so for part A, we don't need double. And so we just add a 0 here for the higher bit, or sorry, we just add a 0 here for the higher cell of the number. But essentially what this does is it's just the brute force implementation. So what we do is we iterate from 1 up to the number, we multiply the iteration counter and then the number minus the iteration counter together, and then we get the number of values that are above a limit. So the alternative to this is you can use a binary search or you can do the quadratic formula. I just spent so much time on this problem getting all the double math working that I just went with the brute force solution, but I might come back and clean it up later. So once we have this, the brute force works pretty well for part 1. For part 2, it does take about 5 minutes when I run it in QEMU on my laptop. And so I'll walk through the part B solution. Essentially, we parse the input so we have all of the numbers in each cell, and we're supposed to combine them all together into a single number. And so what I do is I just iterate over each of the cells, I multiply by 100, and then I add. So it's just like, first number multiplied by 100, second number multiplied by 100, third number multiplied by 100, add them together, and then you have your values for the time and the distance. And again, the distance is a double. It's a 64-bit number, and so we just have to store it in 2 values, which is the lower and the upper cell, respectively. And then we also multiply by a larger number. We multiply by 10,000 as opposed to multiplying it by 100. And so m star mod is the m star divide. So m star divide is the double in math that we use here. And then u m star and d less than are also double operators. And so once we do that, we run solve A, we run solve B, and that's our answer. So yeah, this one was, like I said, a bit challenging just because I had to convert a double library into Dusk OS 4th. But I thought it was an interesting challenge, and then hopefully these double numbers are useful for future days. If you enjoyed this content, thanks again for watching, and make sure to subscribe and hit that bell so you can get notified every time I get on this camera and start talking about Forth. So thank you everyone for watching, and I'll see you next time.